So today we're going to talk some more about conditional statements, and we're going to be looking at section 3-4. And what we're going to be talking about, some of the topics that we're going to be going over are, we're going to talk about converse, inverse, and contrapositive, which are different ways of rewriting conditional statements. We're going to be talking about alternative forms, meaning different ways besides using the words if and then. We're going to talk about biconditional statements, and we're going to talk about just summarizing some of the truth tables that we've learned. So the first thing we're going to look at is converse, inverse, and contrapositive. So we start with our conditional statement with the P and the Q value, P being the antecedent and Q being the consequent. And we write that in an if-then format. If I switch the P and the Q value, then I have created what we call the converse. So the converse, again, these statements will always start with the word if. The converse is when you take the antecedent and the consequent and you switch them. Inverse is when you take the antecedent and the conditional statement and the consequent and you negate them. In other words, you do the opposite of them. So again, you do not change the order of those two statements, you just negate them. And then the contrapositive is when you do everything. You switch the two terms and you negate them. So let's look at this example. The part about the statement that says, I live in Wisconsin, is the P statement. That's your antecedent. The Q statement is, I shovel snow. That's your consequent. So for the converse, we want to switch the P and the Q. So if we switch the P and the Q, you would have the statement, if I shovel snow, then I live in Wisconsin. Okay, with the inverse, we're going to negate the P and we're going to negate the Q. Now when we do this, we always go back to the original conditional statement that we started with. So if I negate the P, I would end up with, I do not live in Wisconsin. And if I negate the Q, then I would end up with the statement, I do not shovel snow. So if I wrote the inverse of this statement, I would write, if I do not live in Wisconsin, then I do not shovel snow. The contrapositive is when we switch them and we negate them. So I would have not Q implies not P. So what we would do is we would switch it. We would talk about shoveling snow first, then when we talk about Wisconsin, but I also negate them. So if I do not shovel snow, then I do not live in Wisconsin. And that's what we have as our answers there. So let's say I had the conditional statement, instead of having words, what if I had symbolic form and I said the conditional statement that I start with is not Q implies not P. So if you think about this way, you have to sort of ignore your P's and Q's. This first part here is my P value. The second part here is the Q value. Or if we want to think of this a different way, maybe it'll make it clear for us. The first part here, let's call that R. And the second part we'll call T. So when we do the converse, we switch them. So T would go first and R would go second. When we do the inverse, we negate them. So we would have not R and we would have not T. And the contrapositive, we switch them and we negate them. So we would have not T implies not R. Now if we go back to what we had, T was not P and R was not Q. So if I wanted the converse, I would have not P implies not Q. That's my converse. If I do the same thing here, the negation of R would be the negation of negative Q. The negation of T would be the negation of negative P. So double negatives ends up being just Q, so this would be my inverse. The contrapositive, again, is the negation of T, which is the negation of negative P. And negation of R would be the negation of negative Q. So again, the double negatives ends up with P and Q, and that is your contrapositive. Okay? I hope this helps a little bit. All right, so a conditional statement and its contrapositives are equivalent statements. So that is just simply saying that the statements P implies Q is equivalent to the contrapositive, which is not Q, implies not P. So simply what this means is that if I did a truth table for P and Q and not Q and not P, I would end up with the same final results. And in the opposite, if I said the converse, which is Q implies P, is equivalent to the inverse, which is not P, implies not Q. So that's all this is saying here with the equivalencies. All right, so some alternative forms of writing conditional statements, instead of just saying if P, then Q, I might say P is sufficient for Q, or Q is necessary for P. A couple of them that are important, if I see something like only if, typically when you see the word if, you want to put that as your antecedent, but in this situation, the antecedent would be the part in front of the only if, and the Q would be your consequent. So let's look at an example here. You'll be sorry if I go. So I want you to write this as an if-then statement. So typically, when you see the word if, then you want to write that as your conditional part. So you would say, if I go, then you will be sorry. Okay? Now here's the exception. When you see only if, then you don't want to write the yesterday was Saturday as your antecedent. You will write if today is Sunday. So this will be your P portion of the problem, and this will be Q. So you will write if today is Sunday, then yesterday was Saturday. And the last one, all chemists wear lab coats. You have to think in terms of dividing the problem into two parts. So chemist is the first part, wearing lab coats is the second part. So you would say something to the effect of, if you are a chemist, then you wear a lab coat. I'm just going to say coat to be a little bit briefer there. So those are the answers we got. So if I go, then you'll be sorry. That was our first statement. The second statement, because of the only if, you don't change the order. You leave it as P and Q, and you say, if today is Sunday, then yesterday was Saturday. And then the last one is something like, if you are a chemist, then you wear a lab coat. So a biconditional is what we refer to as a compound statement, or an if and only if statement. A very common abbreviation is to use the IFF, which is if and only if. These are called biconditionals, and it's symbolized with the double-sided arrow. So in order to evaluate a biconditional, that means the conditional statement and the converse must be true. So if we think about it this way, the conditional statement P implies Q and, I need parentheses here, and Q implies P must be true in order for this to be true. So that's why we've got the word conjunction. The conjunction of the two conditionals must be true. So this is a truth table, or this is the way that it would look. So what we're looking at is we're comparing it to our truth tables that we did the last couple of sections, where we had our truth tables and we set it up and we said true implies true is true. Sorry, I had to get my paper. We had our conditional statements that said true implies true is true. We had the conditional statement that said true implies false. And again, we're just using our truth table that we had a couple sections ago. I just don't want to say it wrong, so I wanted to make sure I looked it up. We had true implies false is false. I'm sorry, true implies false. I'm sorry about this confusion. True implies false. I said that right. It was false. False implies true is true, and false implies false is true. So when we look at that, when we have an if and only if statement, we want to make sure that PQ is true and QP is true. So we have to look at both conditions when we're looking at the biconditional statements. So let's look at this example. 5 plus 2. Okay, 5 plus 2 is 7. So 7 equals 7 is a true statement. If and only if 3 plus 2 is 5. So that's a true statement. Since both situations are true, since both cases are true, then our biconditional statement is a true statement. Okay? So then when we look at the second example, 3 is equal to 7 is false. Four is equal to 4 is true. So since one of them is false and one of them is true, our overall result will be false. For the next one, we have 13 equals 12, which is false. We have 16 equals 16 equals 11, which is false. And since both of them are false, our conditional statement is true. All right, so just a quick summary of what we have with truth tables. Negation means you're taking the opposite value of both of the terms. So if it's true, you take the false value. A conjunction is true only when both statements are true. So conjunction, another word that's a key word with a conjunction is the word and. A disjunction is false only when both of the statements are false. So another way of thinking about that is a disjunction is true when one of the statements is true, and the key word for disjunction is or. And a biconditional statement is true only when both statements have the same truth value. Only when both of them have the same truth value. So if we look at that table that we looked at just a minute ago with the biconditional statements, when we look at that statement, you'll notice that when both of them are true or both of them are false, the results were true. Otherwise, the results were false. Okay, I hope this information is helping you, and keep in touch with me in terms of how your progress is going, and let me know how you're doing. Talk to you later.